Packaging and circuit boards. IC packages. ICs are encapsulated in protective packages. An IC is bonded into a package that serves several purposes. It protects the IC from moisture and airborne contaminants, provides electrical connections, removes heat. There are numerous different kinds of IC package, each with different physical, electrical, and thermal properties. The choice of package depends on the number of connections required, the environment in which the product is to operate. Within a package, the IC is fixed to the bottom of a cavity. Fine gold wires are connected from pads on the edge of the IC to points on the package's lead frame, which is the metal framework leading to the external package pins. The cavity is then sealed to protect the IC and the wires. For a high pin count, high performance IC, using bond wires introduces mechanical problems and delays and degrades signals. Recent packages for these ICs have adopted flip chip technology. The connection pads on the IC are covered in conductive material, forming bumps. IC is then flipped over and affixed to the substrate of the package, with the bumps in direct contact with the substrate connection points. The connection points lead to the external pins of the package. Printed circuit boards or PCBs. The packaged ICs and other components in a system are assembled together on a printed circuit board, that is PCB. PCB consists of layers of fiberglass or other insulating material separating layers of metal wiring. The metal is deposited in a layer on a fiberglass sheet and then etched using a photolithographic process. Several layers are sandwiched together. Small holes are drilled through the layers and coated with metal to form connections called vias between the layers. The completed PCB contains all the circuit wiring needed for the product. Through-hole PCBs. They are suitable. The suitable IC packages for through-hole PCBs are DAPs and PGAs. A through-hole PCB includes additional metal-coated holes into which IC package pins are inserted. So, a solder, a metal alloy with a low melting point, is melted into the holes to form electrical connections between the pins and the PCB wiring. Products using this form of manufacture need ICs in insertion type packages. DL inline packages are one kind of insertion type ICs. They have two rows of pins with 0.1 inch spacing. They come as SSI and MSI components. They are relatively large and limited number of pins. Largest practical size of DAPs is 48 pin. ICs requiring more pins can be packaged in a pin grid array PGA package. It has up to 400 or more pins. These kind of packages are used for ICs such as computer CPUs. Advantage of through-hole PCBs. First is they can be manually assembled since the component sizes are manageable. Good for low volume products. Surface mount PCBs. Suitable IC packages are QFPs, BGAs. In surface mount PCB, components are mounted on the surface rather than being inserted in holes. Advantage is that reduced manufacturing cost for higher volume products, finer feature sizes, increased circuit density. Surface mounting IC packages have pins or connection points that come into contact with a metal pad on the PCB. Solder paste is applied between each pin and pad and subsequently melted, forming the connection. There are numerous different surface mount packages. Some of them are shown in figure. Quad flat pack QFP packages have pins along all four sides and are suitable for ICs with up to 200 or odd pins. The spacing between pins varies from 1 mm for the packages with fewer pins down to 0.65 mm for the higher pin count packages. Fine pitch QFP packages allow increased pin count up to nearly 400 pins by reducing the pin spacing to 0.4 mm. QFP packages are not suitable for manual handling and assembly. The most common package is used now for high pin count ICs is the ball grid array BGA package. BGA packages can accommodate ICs up to 1800 pins. Multichip modules MCMs. Multichip modules attach the bare chips to a ceramic substrate rather than placing each IC in a separate package and assembling several packages onto a PCB. Interconnection wires and passive components, that is resistors and capacitors, are also printed or soldered onto the substrate. The complete module is then encapsulated with the external connections made through package pins on a PCB. Even denser packaging can be achieved by chip stacking. This is ideal for high density applications, example cell phones.